The linear regression approaches that we used in our previous course represent some powerful methods. Importantly, while these techniques allow for a simultaneous examination of multiple explanatory variables, their goal is to understand how these variables are related to the response variable in a linear fashion, and to generate only a single prediction equation that works for the full sample. In fact, when our data has large numbers of explanatory variables that may interact in very complicated ways, building a global linear model can be difficult, if not foolish. In this session, we will review decision trees, a data mining method that allows us to explore the presence of potentially complicated interactions within our data by creating segmentations or subgroups. Like linear regression, decision trees are statistical models designed for what are known as supervised prediction problems. Supervised prediction is a generic term that encompasses many related methods, including linear regression, pattern recognition, discriminant analysis, multivariate function estimation, and supervised machine learning techniques such as decision trees. In supervised prediction, a set of explanatory variables, also known as predictors, inputs, or features, is used to predict the value of a response variable, also called the outcome or target variable. Decision trees are so named because the predictive model can be represented in a tree-like structure that looks something like this. When the response variable is categorical, the model is called a classification tree. Decision trees are read from the top down, starting at the root node. Each internal node, in blue, represents a split based on the values of one of the explanatory variables. Importantly, an explanatory variable can appear in more than one split throughout the tree, as variable B does here. The green terminal nodes of the tree are called leaves and represent final subgroups based on the combination of previous splits. Here is a classification tree that was grown with data from Wave 1 of the AdHealth survey, including youth in grades 7 through 12. 24 possible explanatory variables were included to test associations and to generate decisions, that is, branches, that best describe subgroups or segments of the sample with either high or low proportions of our target variable, regular smoking. Before we interpret the model, let's look at a list of variables included for consideration in the analysis. Our response or target variable is regular smoking, and it was measured based on the answer to the question, have you ever smoked cigarettes regularly? That is, at least one cigarette every day for 30 days. The 24 candidate explanatory variables include those that have been found in previous research to be associated with regular smoking behavior in adolescents. Although classification models can handle categorical variables with more than 2 levels, and those that include ordered categories, in conducting my data management, I chose to create a series of 2-level or binary categorical variables. These include gender and 6 separate variables for race and ethnicity. That is, Hispanic, White, Black, Native American, and Asian. Substance use was measured with individual questions about whether the adolescent had ever used alcohol, marijuana, cocaine, or inhalants. Additional categorical variables included the availability of cigarettes in the home, whether or not either parent was on public assistance, and any experience with being expelled from school. Finally, my quantitative variables included age, alcohol problems, a measure of deviance that included such behaviors as vandalism, other property damage, lying, stealing, running away, driving without permission, selling drugs, and skipping school. Another scale for violence, one for depression, and others measuring self-esteem, parental presence, parental activities, family and school connectedness, and grade point average were also included. For more complete details on how these variables were constructed, see the Durker et al. 2004 paper from Prevention Science and the SAS program called Decision Trees Data Management that I've made available as additional resources.